Good day. In this activity, I will compare how C++, Java, and C# evaluate expressions, particularly when functions with side effects are involved. The goal of this activity is to differentiate the evaluation techniques of different programming languages on expressions. Before rewriting the program in other languages, let's identify the original programming language used. So as you can see, the original language of this code is C. Actually, this we can tell this because the program uses pointers such as asterisk E, K, okay, and it passes variable using the memory addresses with the ampersand symbol like and I, like this one. The code also modifies values through pointer differencing using asterisk "p", "k", which is a core feature of the C language. Mm, Language like Java and C# do not support this kind of a pointer manipulation. Although C++ can compile this program, the syntax and programming style clearly follow C programming, not C++. Therefore, this program was originally written in the C programming language. Since this activity needs different programming language, so we will be using different online compiler for us to easily run the code in different programming languages without installing into our PC. So let's open first an online compiler. We are now in the online compiler of AC programming. So as you can see, it's already open and I already deleted all the code that was given here, or because when you open a compiler of a C++ online or any programming languages online, there is already a default code that is already typed here. Um, that is why I already deleted it. So I open a C um, online C compiler in the programming the same platform, another online compiler in the programmers, which is in the C++ and also the Java and in C Sharp, so that we could easily run the code in different programming language. Okay, so I will also explain the program line by line and discuss its logic. Alright, so let's start here in C so that we could run this code. But we really need first to put a header and some part of the program to run this code before we could run this. Okay, so let's start with um, hashtag include stdio that is. Alright, so this one includes the standard input and output library in C, so it allows us to use functions like printf to display output on the screen. So I think we did it many times already since the previous activity that I made in this um, kind of video is in C. So next is we will be now putting the code that we had here, this one. Okay, let's start with this part, or I think we could like copy paste this one. Okay, let's just copy paste this since this is the thing that we will be running in this activity, the original code. Okay, let's start with the first line here, and then in the second line, number two. Okay, here we define a function named fun. Okay, in this part, we define a function named fun, and then it returns an integer value, and then the parameter int times k means we access the value stored at the address passed to the function. Then we add 4 to that value, and we add 4 to that value. So in this part, we add 4 to that value. So this directly modifies the original variable. And then this part, that returns 3 asterisks, and then closing up in parentheses, and then asterisk k inside, and then minus 1, it calculates 3 times the updated value of the variable, then subtracts by 1. The result is returned to the calling function. Okay, so in this part, we are now in our, we're done with the first part of our, with our code. Okay, and of course, um, we are now in um, we are in the main function. Next to that is we will go to our main function, okay, which is our void main. But um, I think there would be something wrong when we will just put here void main, but later on we will realize why does it work. I mean why it doesn't work here um, in C. Okay, so yeah, we are now in the main function, and then but okay. Next to that is, but actually, here in this main function, this part, supposedly where the program execution begins. Okay, but I think we could put here in the original code uses where's that? Void main. So this one, because we just copied it here from our original code given on this activity. We just copy and paste the code here. So the original is this one, the void main. Okay, but modern C standards require the main function to return an integer. So to fix the compilation error, because as what I have said a while ago, there will be something wrong that will happen with this because this we are using modern C standards of a compiler, so it requires main function to return an integer. So for us to correctly or avoid compilation error, and but it will still preserve the original logic. Okay, so that's why we will be changing this into int main void. Okay, that's why we will be putting inside the void. Okay, in the closing up in parentheses, we'll put the void, and then the main would be outside. This is it's one. It would be in main. Okay, right. So in this part, um, yeah, that it returns an integers because we are using EC standard, and it really requires the main function to return an integer. There would be an error into that if we would run using that original void main function. Okay, so that's why we changed it into int void main. Um, sorry, int main void, and added return 0 after this, okay, at the back portion of it. And then it does not change the behavior of the program. It only makes it standard complaint. Okay, so that's it. That's fine. And the next one is here we in this part here we declare for integer variables. So we have here we have so After we have the main functions, after we're done with the main functions, we are now in next one. So in this I, and then of course in this part, um, here we declare four integer variables. We have I, which is equals to 10, j equals to 10, and then sum 1 and sum 2. So variables I and j are both initialized to, to 10. Um, while the sum 1 and sum 2 will store the result of the expression. So that's why we just remain it, just declared it. Okay, the next thing is we have here in the below we have sum 1. So sum 1 I over 2 plus 1 um, ampersand I inside a close and open parenthesis and with this semicolon. So in this line we calculate sum. We just calculated here the sum, alright? And then after that, after we calculate the sum, this line here, the sum 2, okay? Um, yeah, we have the next line, which is sum 2. So first, let's discuss the sum 1, okay? It divides, so first I divided by 2, okay? I divided by 2, I divided by 2 divides by 10, divides by 10 by 2. And it divides because the value of I is 10, so therefore it's 10 divided by 2, okay, which equals to, let us say, 5 here. Okay, so that is equals to 5. And then we call the function fun passing the address of I using ampersand. Plus 1 using ampersand I. So inside the function, um, 4 is added to I. So I becomes 14. Okay, so I becomes here 14. Alright, so next is after we um, after 4 is added to I, so it becomes 14, and then the function returns 3 times 14 minus 1, which equals to 41. Then finally, we add we add 5 and 41. The sum 1 becomes 48. Okay, so the sum 1 that we have here becomes 48. Okay, next is sum 2. For sum 2, 1 ampersand j plus j divided by 2. So now we can compute sum 2 and we call the function fun first, passing the address of um, j, passing the address of j. So in this function, 4 is added to j. In this part, 4 is added to j. Um, and making it 14. The function returns 41. Then j divided by 2. J divided by 2. So our j here is, yeah, but our j here, and since it becomes 14 divided by 2, so which equals to 7. So sum 2 becomes 41 plus 7, which equals to 48. Okay, so after that, of course, we need to show the result of this since for us to know the differences or how does if it really works well, we really need to show the what is that how or the result of the sum one and sum two. Okay, so let us see if this really works. That's why we will add in the last part we will add what's that print this into this. Okay, so let's gonna print the result of sum one and sum two. Okay, for us to see if it really works. Someone responds in recent speech, um, new line, and then it's gonna have another, and it's gonna call the value sum. Okay, then it's gonna be another one. So, the first answer, I forgot the publication. Then lastly, of course, we need to return this into zero. Put some into letter. Semicolon. Right? So let's gonna try to run this one. Because if you will just been running along this one, it will gonna work. It won't gonna work. Because we don't have header into this, we don't need something to make this code run. So that's why we put or we added something into our code to make it run into the run. Let's gonna see if it will work and let's gonna see if it really works here. It takes a lot of time though. Mm-hmm. It takes this so long. Oh, okay. There's an error here, so we need to fix it. Last one with hour. That's well. Okay, so we're done. We're done with our we're done with our code. So yeah, it's already done. I think we need to put a little bit of space here. Oh, it's not working. Let me check again. So it's working, but oh, sorry, I got a mistake with um because I don't know why it's not working, but the symbol is wrong here. It should be backslash. Let's see. Oh, I'm sorry. It should be okay. Wait. Alright. So, as you can see here, I think I already explained this part that why it becomes 46. Okay. Because in this part, the sum I divided by 2, um, this first thing here is it's I divided by 2. So basically when we say I, that equals to 10. So 10 divided by 2, so it equals to 5. Then we call the functions fun. So we call the fun, passing the address of J using and I mean ampersand I. And then inside the function, 4 is added to I, so it becomes 14. So, and after that, the functions then return 3 times Mm, that's why 14 minus 1, which equals to 41. Alright, so as you can see here in this, why it becomes 46, it's because in this part, we have here I, which is the value of I is 10. So I divided by 2, that would be 5. Okay, will give us 5. Then we call the function fun. We call the function fun here, passing the address of I using ampersand I. So this part. And then inside the function, 4 is added to I. Okay, 4 is added to I inside our function. And so I becomes 14. I becomes 14, and then in this, the function then returns 3 times here in this part. So it returns 3 times, and 14, 3 times 14, so therefore it becomes 42 minus 1, that's why it becomes 41. And then after that, finally we added 5 and 41. We added 5 and 41, so it becomes 46. And then after that, also the 48, why we have here 48, it's because um, it's because here we started with 1 ampersand j. Um, we call the function fun first. Okay, that was the first thing that we did. We call the find function first, and then passing the address of j, which is this part, the ampersand j, and then inside the function, 4 is added to j, which is our j here is 10 plus 4, then um, that makes 14. Okay, making it 14. Yeah. Then this function, and then using this um, going here into our retain functions, functions then return 3 times, and then um, 3 times and returns 41. So therefore, j divided by 2 becomes 14. J divided by 2 becomes 14, and then divided by 2 again, which equals to 7. Okay, so sum 2 becomes 41 plus 7, which equals to 48 in this one. So, in this, that's why we had here sum equals 48. Okay, so yeah, and then the last part is we return um, 0 lines and ends the program and returns 0 to the operating system, indicating that the program executed successfully. Okay, so that's why when we run our code, the output is sum1 equals 48, as sum1 equals 46, and sum2 equals 48. Alright, um, this program demonstrates how passing variables by addressing using pointers allows a function to modify the original variable. So it also shows how side effects inside expression can affect results. Alright, so now let's gonna try this to the other programming languages. Alright, so we are done in the original programming language of our activity. So we're in the programming language. So this time, before converting the program, since our activity, according to this activity, we need to run this program in C++, Java, and C Sharp. So before converting the program to Java and C Sharp, let us first compare the original C code with the C++ version and understand their logical differences. So um, let's just gonna copy and paste this code from C to the C++, but let's just leave the header because we will be using the header for C++. Okay, so let's just copy and paste it to the and let's go to this online compiler or C++. Let's just select everything except the header. Let's delete this one and then paste everything here. And we also so we're done copying and paste. So this time the only thing that we'll be changing is aside from the header, of course, the last part, which is this one, the print if. Because as you all know, here in C++, they will not be using primitive to display output, but they will be using cout or steady state double quotation cout. So it's gonna replace it with the syntax of C++, where we can display the output. Okay, so now the end now. Okay, after that, let's just gonna copy and paste this because it would not take a lot of time. And then use the variable to sum. Alright, still it's returned to 0. It's gonna try to run if this will work. Okay. The only thing that we change is the header and also the syntax on how to display output here in C++. Takes really a lot of time to run. I know what happened on the internet lately because we have a bad weather. Uh-huh. Can you check what happened when it becomes 248? Oh, I see. The sum equals to 2. It should be sum 2. I'm sorry. Okay. It's gonna run it again. Because the output becomes sum equals to 148. Okay, so the same as what the output is just the same with our previous one. Okay, so basically, um, maybe you'll be asked, are they really logically different? Because it's just there, it's almost the same, right? In terms of core logic, the original code and the C++ code are actually the same. Both versions use functions that receives a pointer and modifies the value of the variable by adding 4 and then this part by adding 4 and then returns 3 times the uploaded value, and then minus 1 in this function. And this logic remains. So, so the computation itself does not change. It really does not change. And also, the only thing that was changed here is how the output statement is played, or the syntax for the output statement is played. Um, yeah, as what I had said a while ago, this uses print if. You can see here, it uses print if, while here, we uses stay out to display the output. But it does not affect the logic, it only changes the syntax. Okay. The most important logical discussion is not C versus C++, but how expressions are evaluated, especially in this line. The function modifies the value of I. So, and the division also uses I. So in C and C++, the order of evaluation of operator and operands is not strictly defined. So this means the result will depend on which part is evaluated first. So the real logical concern is side effects inside expression, not the difference between C and C++ syntax. So basically, the logic of the original um, C code and the C++ code is essentially the same. So they are just really almost the same. We just copy and paste here the code and then just change a little bit. Not the logic, not the function, not the logic, but um, only a little bit of syntax that will change. The difference are mainly structural and syntactical. The important concept demonstrated by both versions is how modifying a variable inside an expression can lead to different results depending on evaluation order. Okay, so we are done with our C++. Now let's go to our next this, programming language, which is our Java. The Java, okay? Or we are in the programming online Java compiler. Okay, so we are now in the Java online compiler. So we're using programming. Um, okay, so last time in C, uh, going to C++, we just copy and paste the code, okay, coming from C going to the C++. But by this time, so we all know that Java has no pointers. Okay? Java does not allow ampersand I. There are really a lot of changes in our code, in our original code. So that's why we cannot directly run this in Java. Um, okay. Um, because there are lots of changes. Let's go back to our original code in C. Um, we really need to change the header files because our header, because we're using Java, and then we will in Java in yeah in this C the program starts directly with the main functions. Okay, so here with the main function, but in Java every program must be inside a class, so we need to create a class. So that's why we're gonna be changing this parts, and then um, also the main method format, of course, this part will be changed. And then aside from that, let me check what else. Pointers must be removed. So this is one of the biggest changes to this part. To be this is one of the biggest changes. Java does not support pointers. like say that. Okay, and then we also, what else? The function. Yes, this function changes. Another thing is the address operator is removed, so just like this, um, and I or ampersand I and ampersand J. So this would be removed because there is no ampersand symbol in Java. And the output statement also will change. So of course in Java they're not using printf, they are using system that output print. That I could check system that output print. Yeah, LN. Or that just the print. Okay, so let's gonna what you gonna do with this? Um Maybe we could make it one by one. We will type it, we'll erase everything first here in Java, and then we will then start all over again because there are really a lot of changes here. No pointers, no ampersand, no set functions, all together with the print. So, and Java requires the class. So you really need to like type everything. But though there are changes, but the logic will remain. Okay, the logic will remain. So I'm gonna discuss it one by one. Okay, so we're gonna start with. So it's gonna start it from the top. Okay, so in Java, every program must be untied to class. So unlike C, we execute or directly from main. So Java requires class definition. So the original C program did not need that structure. So therefore, we need a class system, or we will be making a class. For us to make class, so let's say public class, excuse me, public class main, and then we're gonna put it in close and open close and open curly brackets. Okay, so that's not gonna enter that one too far because last time around I got an answer because I got there are too many curly brackets that I put. Okay, so this time we're done with the class. The next thing that we will be doing is we need to define the font because here we had also our font. So in this part we need to define our font. Because in the original C code, the functions was written like this, right? Um, wherein the function receives a pointer to an integer. In Java, pointers are not allowed, so that's what I told you a while ago. So instead, we pass an object of type which contains the integer value. So type into to pass the object of type which is in let's go see ink folder. Okay, so for us to start that, we need to first um, define our function. That would be static int fun new folder. Okay. Alright, so the next thing, is, of course, we're gonna put that one in. Um, also an alternative brackets. Um, Next thing that we will be doing is this asterisk plus b equal to 4. Right, so let's gonna try to um, in that part in C, um, yeah, we use asterisk here, yeah, here plus um equals 4. So to modify the value stored at the memory address. Here in Java, the object fills using dot notation, so that would be say that value. Therefore, what will happen to that is it will become say that say that value plus 1 1. Okay. So again, we just use here for us to access the object field. So we use this that notation, okay, that value. So although Java does not use pointers, the object allows us to modify the original value indirectly. Okay. So next is let's go into so say return three asterisk say that value is one. Okay. So as you can see in this part, this is logically identical to the C versions, okay, that we had, which is this one, this part. Okay, the only difference is syntax, because instead of differencing a pointer asterisk string, we access the object field with that k value. Okay? So that's why we are using here k that value. Next is our um, main method. Okay, so we are done with this part. We're done with the original code. We are done with this part. We are okay. So we are done with our return statement. So this time let's go on with our main method. So let's go back with our key. In our key, the main function here, we use in main void. The main function here we use in main void. But in Java, the main method must follow the exact format, which is the public static void main string art. So that would be the thing that we will be typing here. Okay, let's gonna make the main method of in Java. Okay. Okay. So we have now our main method. Um, because we use this one, the exact format that we need here in the exact format in Java, because this is required by the Java version 2. So for us to make main method. Then what we will be doing is creating variables as we've gone with our original one. So we create the variables after making the main method. So in this part, in C we declare simple integers like int I equals 10. But here in Java, since we cannot pass integer by reference, we will wrap the integer inside the class called int folder. Okay, so let's gonna try to do that. So int folder called int folder. Um, Semicolon, and then also with the J, let's just copy and paste this one. It's the variable. Okay, so we have here our um ink holder. Okay, so in this part, we are again um we are perfect. Since we cannot pass the integer the reference, so we need to wrap the integer inside a class, and it is called int holder. And this allows us to modify the value inside the function, similar to how pointers work in our original code or in C. So that is how our variable is created. So this time let us declare some variables. Um, so simply we will just declare this is just almost the same in C, because here in Java will also just almost the same in C, the way they declare the variable. So sum one and also with sum two. So we have here sum one and sum two, that the variables of these, and then this is just a declaration of integer variables to store the results. Okay, so we're done. Now let's go on. Alright, so since we are done declaring the variables here, um, let us now do our first expression. Okay. Um, in Java, we need to remove the address operator and because Java does not support pointers for the ampersand. So we use I dot we will be using I dot value to access the integer stored in the object. So for us to do um, this first part, we need to use the I dot value. Okay, so it's gonna start doing that. Let's say sum one equals I dot value divided by two, and then plus one inside SDI, and then um, semicolon. So um, so yeah, we really need to remove the address operator ampersand. So this one, we need to remove this and the ampersand I, because it does not support here in Java. It does not support pointers. So that's why we use I that value here, and then to access the integer, um, to call that, stored inside the object. So also, unlike C, Java guarantees left to right evaluation of expression. So this means the I dot value divided by 2 is evaluated first before the one I. Okay, so next let's have the second expression. I think let's have sum 2, okay, equals um, 5, and let's gonna put J inside. Sorry, gonna put J inside, and then plus, let it close enough in parentheses, J dot value, divided by 2. Okay, divided by 2. So this is just similar to the second expressions that we had here in C. Um, but in this part, again, Java removes pointer syntax and uses object reference instead. Okay, so next, let's have the output statement since we are done with our um, second expression. So let's gonna try to get the output. Let us see if it will display the same output that we had with C. Okay, so let's gonna put the system back out. Copy and then it's gonna one account. It's gonna put inside the closing operator system so that it will display and copy and paste the value of some account. Okay, so yeah, we are done with this. So we're telling this to print this one and then with the value of some one. So let's just copy and paste with that, and then remove this and replace this with some two, which is the output of our second expression. Okay, so but we're not yet done. Okay, let's read first the encoder class. Okay, so this class is created, or we need to create that um, class to simulate pass by reference behavior. So actually in C, we pass memory addresses using pointers, but here in Java, we wrap the integer inside an object, so the function can modify its interval value, right? So let's gonna end this, close this one first. So this is the close of our this whole let's gonna close it first with our main method, and then let's find the other one, the close of. Gonna check. Okay, public name. Alright, so now let us make a what's that? Int holder class. So after this, okay, so let us say class int holder. Int value. Okay, so at this point, Again, we are making first a mm, int holder class because that's what we have. I have told you a while ago. Um, this is this class is created to simulate pass by reference behavior. We need to wrap the integer inside an object so the function can modify its what's that internal value. So um, and this part after that is we will be creating um, another um, constructor. We'll be creating what do you call that? Constructor to initialize that or initialize the object value when we create the new int holder with a value of 10. So for us to do that, let's go introduce this one and then let's come say int holder. Mhm. And then we're gonna put inside the boost value, the class value. It is a constructor. So we are initializing here. Um, I mean, it, yeah, it initializes the object value when we create it. When we create it using int holder with a value of 10 here in this part. So check. I think we're almost done. It should be done. Since we are done creating the last part, the int holder class, and then the int holder or the constructor. Okay, let's gonna try to check. Close of this, I will close. Let's gonna try to run. I'm not really sure if we got some error with this or if it's really slow left. So let's gonna try to run. If it gives us the same okay. So there is an error here. Let's gonna try to see. Um, slide 19. That's the small one. Okay, so we got it right. We got a same output that we had in the original what's this? The original programming language. Okay, so as what we have discussed. Okay, so we are abandoned our Java code. So as what we have discussed last time, that previously, as what we have discussed previously, we have a lot of changes in this code, but actually the logic would remain itself because here in Java, what we have said a while ago, it has no pointers, do not allow ampersand or operators, and does not allow int asterisk those does not use the primitive and same way requires. And then also we will need class here. So there are a little bit of is that changes here. So let's see if it works. I mean the logic works itself. Okay, so alright, so um the most important in this part is that um the difference between C and Java in this program is um, is that how they handle memory and parameter passing. C uses pointers and allows direct memory manipulation. So Java does not allow pointers, so simple simulate reference behavior using objects. So and additionally Java guarantees left to right evaluation of the expressions or of a certain expression. So while C does not strictly guarantee evaluation order. Basically, in Java version keeps the same logical computation as the C program. So, but the syntax and memory handling mechanism are different, of course, because they handle differently. And Java replaces pointers with objects and enforces stricter evaluation rules. Okay, so I think we got the difference um, between that's those are the differences between C, the original code that we had going to Java. Okay, so now let's have next the last, okay, the last programming that we will be using, which is the C sharp. So after Java and C sharp are I think there's a little bit um, difference only compared to from C++ or from C to Java. So like a little bit why. I think C++ and C are they are classmates and Java and C Sharp are also classmates or maybe they are sisters or brothers. Okay, so let's gonna go to C. Okay, let's start here in C. So we open it already. The compiler and the unlike compiler of C sharp. Sorry, it's a C sharp rather. So um, actually the Java and C sharp was almost the same. Changes from the original code. Maybe the header file. Yeah, I think that's really the thing that will really change. The header file. The pointer parameter needs to be removed and the address operator needs to be removed also. Um, Also the main method format um, together with the output statement. It use different output statement. Okay, so I think those are the changes that they possibly happen here. So let's gonna code it one by one again. Since we are rooting from the original code. But I think we could put change from Java with us together. Maybe we could copy and paste this one. Um, I don't know. Let's gonna try that one. We need to change a lot here. Okay, so let's gonna try to um just stick to the original one. Okay, so let's erase everything in here in the console of um C sharp. Okay, and let's start with the header. Okay, so um, let's start with the header. In C sharp, we will be using um, system, using system, or using system. This one is a header. And then semicolon. This is used to access the console class to input and output. So in C, we include hashtag include stdio.h to print f. The idea is the same, so importing functionality for standard input output, but the syntax is different. Okay, so now let's go forward with our class declaration after this. So let's gonna declare a class. Let's gonna say using curly brackets. Great. So this is our class. In C sharp, all code must reside in a class, inside a class. Or while in C, we did not need a class. We could just write in main right in our previous code. But here we really need to put all those codes inside the class. So this is one of the main differences between the C and the C sharp. Though the difference with these two are just having sharp with its with the C sharp, right? But they are really very different. Okay. So now let's gonna move to the function definition. Okay, so let's gonna have this one first. Inside our class, let's gonna put the function definition. Okay. So actually this part we gonna making this one first. This is part of our part of the original code. So this part. Therefore we're gonna make the one first. Okay, so that's why we will be making the function definitions here. And after that, it's gonna make this. Okay, so the if and k, what's it name? This part, the if and k. In C we use pointers in asterisk. Let's put this one. We use this one, right? We use the one. Um, but here we use this. Okay. The if and k. This one. Um, to address of operator ampersand to modify the original variable. Okay, so and in C sharp, the root end this allows K to how to explain. This allows K the function to modify the original variable directly without using pointers. Okay, so this is the reason why we have this and K to function as to modify allows allows function to modify the original variable directly. And then here the next one is k equals 4. Um, so in C, this part, the k asterisk k accesses the value of the value at the pointer. And here in our C sharp, in this part, um, k is already passed by a reference, so we can modify it directly. And then the return 3 times k minus 1, okay, versus the original one in this part. So same logic as C. The function multiplies the updated value by 3 and subtracts to 1. Okay, so that is why we have this part of our code. This is just almost same with our C. Okay, so we are um, done with our functions definition. Now let's go on with, I think the next one is the main method. Okay, so okay, let's close this and put this still inside our class, the method. Um, so as you can see, I think it's just almost the same method. It's just almost the same with Java that we used a while ago. It's static public static void main is in Java, but here in C sharp we will be gonna using public void main. Okay. Mm, sorry, it's static it's static void main. Got confused with this many programming languages that we use. Close, and then that's gonna have close and open curly brackets and enter that one. Okay, so we are done with our main method declaration here. So compared to the original one, this is they are just using a main void. Okay, so um in C main could be in main void. Yes, and it's a non-standard. But in C sharp, the main method in C sharp, the main method must be static. Okay, must be static, and that is why we and have a string like this. We have a string args parameter. This one, string args parameters that we have. Um, Logic is the same, but this is where the program execution begins. So the next thing that we will be doing is declaring our variables, the same as the original one. Let's gonna declare our variables. Then say int I equals to 10, and then our j still equals to 10, and then our sum 1 without value, and our sum 2 does not have value also. So it's very identical with the declaration in C. Um, but yeah, in this part, declaration integers is to store initial values and result. No change is required here. It's almost the same or identical with our original code that was given. Okay, so the next thing that we will be doing is um, having our first expression for this sum 1. It's gonna do that here in C sharp. So it's gonna say sum 1 equals, gonna put it inside the close and open parenthesis, and it's gonna use I over 2 and add it with define and L I. It's gonna end this with semicolon. Okay, so this is just almost the same with our first expression in the original one. And in C, let's gonna go back in C. It uses ampersand I. Okay, so that's what we have discussed a while ago. The same as Java and C sharp also does not use pointers. So that's why um, here in C, ampersand is used to pass a pointer to the functions. But in C sharp, um, C sharp here, this one is what? It uses ref I to pass the variable by reference. Okay, so um, it works like it's something I divided by 2, and then it's evaluated first. So therefore, the value of our I here is 10. So therefore, I divided by 2, that will give us 5. And the final ref I adds 4 to I, so that will become 14. And then functions returns here, and then the 3 times k minus 1, and that will give us 41. So maybe the output of this, um, I mean, after 41, we still need to sum with 5, or with our um, value, which is 41. The after the return, after the function returns, we still need to add the value of 5, which is coming from our previous division. So therefore, it will give us 46. So the computation logic is exactly the same as C, just without pointers. Okay, so now let's go on with the second expression. I think we could just copy and paste this one, or I think it's different. Yeah, different. Sorry. Let's gonna have sum 2 equals some space fun ref again, and then I. It's gonna add it with I divided by 2, add it with, okay. So we are done with our second expression. So the same as versions in C. We are in versions in C a while ago. Wherein they have this part for the second expression, and then in our C sharp we also had our second expression. But in this part we use ref J. Sorry, this is 3. No, it's 1. So with J, this is not I. Ito, this will be J. Um, yeah, I've got long variable here. Okay. Ref J and yeah, we replace as ampersand J here. So because we cannot use this one here in C sharp. Um, so as you can see, in this part, j divided by 2 is evaluated after the function call the sign. Okay, so the function call the sign. So j is modified inside the function. So j equals 14 and then 3 times k minus 1 that will give us 41, and then the sum will be added to the previous answer of j division, which is 7, so it will give us 48. So the differences between sum 1 and sum 2 comes from the order of evaluation. So this works the same as in C. So that's it. Now let's try to display the output, okay, of these two expressions that we had. It's gonna say here in C sharp, they are using console that right line. Okay, so we're gonna follow that part. Okay, should be inside the closing open parenthesis and inside we will be displaying this one, the word someone mm equals, and then concatenate the value of person. Concatenate the value of some one. Okay, and so we're gonna end that one with semicolon, and then after that we'll just keep copying this one. So change the variable name into something. Okay, and it's gonna try to close and open. That's weird because sometimes I got an error because I have a lot of closed and open brackets. Okay, so since we are done with our yeah, we are done with our code. Let's gonna try to run this one. Let's see if there's some error with this, or I don't know. Well, it takes a lot of time to load and to run. Okay, I've got some error. There's not printing the definition on time. Okay, let's go try to see. So I um, if I want to run. Okay, I fixed it. I think it's only the right line itself. Okay, so same thing as we did, same output with our original um, code that we had. Um, so basically, um, those are some of the um, those are some of our the differences between the C sharp, the Java, and I mean C++, yeah, C++, Java, and the C sharp. Okay, so we are done with all our programming languages, and we compared it already. How does the I mean those different programming languages, how does it work with the given original code? But maybe you'll be asking, what if we were just copy and paste the original? Because according to the instruction, we need to compare the result, and they have the same result actually. If we will be just using the what is that? Oh, if we will just be using the what is that? The standard of standard syntax in every programming languages, because if we would just be using the same syntax and then in that certain programming language it's not acceptable in the other programming language, so therefore it could give us an error. So like this one, since this is coming from C sharp, C originally this is coming from C programming language, and then we're gonna copy and paste this here in C in C++. Though there are just a little bit of change, changes, but if we were just copying and pasted, and then without changing this part that we've got to change a while ago, um, so if we run, it will really give us an error. Yeah, it will really give us an error. Unlike if we will be changing those parts that we have discussed a while ago. Also, with this here, it will still give us an error if we will just run the original one and compare the result. There would be an error to it. So that's why we are just studying the standard in each of the programming languages. Um, standard syntax of each programming languages. Okay, so I think that would be all for today. So hopefully you've learned something from um, I've really learned something from this um, activity, and hopefully you too have learned something from this activity. Thank you so much, and that would be all. God bless everyone. Bye bye.